Hi students, I'm Gunu and I'd like to record a video lecture for the laboratory since this Wednesday is a holiday. So in the last lecture you have learned how to implement a sparse matrix. So I'd like to just describe some application how to solve the problem using a sparse matrix. So let me just share the program handout today. So the title of today's laboratory work is matrix multiplication. So as you know, you have learned how to overload the operator times, but the same is true for the operator insertion. So the insertion operator is for directing to the O output stream. So to the O stream, to an O stream object, you can insert some data item. So in order to overload this kind of operator, you have to define operator insertion, which is same to that if you want to overload the operator times, then you have to define operator times. So in the last example, you have used operator plus in this form. So as you know, if you want to add an integer object a plus b, you know that these two things should be passed to the operator plus. So the arity of the operator plus is if it is a global function, so operator plus, and it should accept int. But as a member function, you may also define this as a member function. You can do that. Int dot operator plus int. So in this case, we are implementing like this. Okay, so we took this kind of approach. The same is true for the shift operator. So the shift operator, so if you want to see out integer a, then you have to define either operator shift insertion to O stream and int, or you have to define the O stream that operator int. But as you know, how can you change this one? Because this is already defined in system. So it is system defined. So the only way to add an operator is this one. So I'll take this approach to overload the operator. So for example, you can overload the O stream int object. So as you can see in this handout, we overloaded here. We overloaded O stream operator, and it is accepting O stream and int. Okay, so since it is a global one, operator O stream and int. So I'll talk about the other tricky reference sign here. So the reference means that it is not a copy of the object, but itself, which is denoted by itself. So it is internally implemented using pointer, but you may regard it as the object itself. So you may think that operator shipped or stream cout, then you want to change the status of cout. So you need reference here. And the returning object of a stream reference is also needed because you have to cascade cout. So cout of an int object is okay, int2 is okay, but you want to cascade it with an end line. So for this cascading, you need to return the all-stream reference. So in this case, you are printing integer object c, a plus b. This is implemented as a member function. But as you know, this is implemented operator cout c. So let me take this example from your Visual Studio Code. Let me change it to Visual Studio Code. So we're sharing this with, sorry, it is somewhat slow. This one. So you have seen that this is very similar to the previous one, and all stream reference is used here. So if you are not returning all stream reference, you can use this as a void. You can do that. In that case, you don't need to return. Just do the end of value is needed. But if it is true, this is also valid for this sample code, because if you build this and let me just check the result of int add is printed 5, but since it is not returning a value, you cannot cascade it. So for example, you cannot cascade end line here. So without this one. So if you try to this one, let me build it, you know that this is an error. So the error message is saying that void type, a type void, and unresolved overloaded function binary operator of insertion. So this means that if you interpret this, it is bound like this. So that means CLC will return void. That is nothing. So how can you insert ENDL here? So in order to ENDL, you just make this return all stream reference with the same reference of the out, and you should return it, return out. So let me build this again. Then there's no error. And you can execute this int add. This is same as before. So that is the reason why should I return all stream reference as a parameter and a return value. So you can safely merge this because the return value of this is the upstream. So you just return this. So the meaning of this statement is that you are returning the value of this. Okay, the returned value. which is the R value. So let me build this again. Okay. And the same is true, but this is not needed because the return is executed lastly once we evaluate the full expression. And as you know, this is not needed because it is left associative in default. So build this one, and you can do that, the same result from intent. Okay, so let me switch it to your handout. To explain today's problem. So beware that all stream reference is transferred to operator since the reference is transferred since the status of the upstream is changed during this operation. And the all-stream reference should also be returned to support subsequent operators on it. So now you know how to implement a sparse matrix. We implemented the sparse matrix in the last lecture. The sparse matrix. And how to convert a square matrix into a sparse one. So also you have learned fast transpose algorithm of a sparse matrix. So for a given sparse matrix, you can implement a transpose algorithm, and then that will return a transposed. So that means if this is n times m, which means the m rows and m columns, you know that transposed matrix is m rows, m by n columns. Then you can multiply them, because for the multiplication you need to, this number of columns should be same to the number of rows. So now, and the resulting matrix A times B should be n times n. Now you know how to implement a sparse matrix and convert a square matrix into a sparse one and fast transpose. So once you transpose a matrix A, then you can do the multiplication. And the resulting matrix of this is, in this case, A is m by n, and A transpose should be n by m, and the result should be m by m. So as you know, the elements of A times A transpose are the inner product of row vectors of A and the column vectors of A transpose. Implement the multiplication of a matrix in C++ using a class named sparse matrix. Note that your program should implement the method transpose. Okay, so please implement fast transpose as far as possible, and the multiplication operator should be implemented. The input consists of m plus 1 lines where m is the number of rows. So the first line is reserved for the dimension of the matrix. The first line contains two positive integers m and n separated by a space. Each of the following m lines contains the element of integers of I plus 1th row of m by n matrix, and I is greater than or equal to 0 and less than m. Where the elements are separated by more than one spaces, your program should print non-zero elements of the resulting matrix to the standard output. So let me take a look of an example. Before the example, let me specify the output. The resulting matrix should be printed to the standard output. The first upper line should contain dr, dc, and k. So dr, dc is the resulting dimension, and k denotes the number of non-zero elements in the resulting sparse matrix. So this is the dimension, and this is the number of elements, non-zero elements. And the positive integers should be separated by a space. The positive integers, that means the RDCK should be separated by a space. The line should not contain any trailing space except a new line. Each of the following K lines, which means that K is the number of non-zero elements, should contain triple. Ith row and jth column and the element, where I and j are the row and the column indices, which is less than, this should be less than dr, this should be less than dc. Sorry, this is not m and n. So you will infer that both of them should be less than n respectively. The triple of the element should be printed in row measure. Assume that the maximum number of non-zero elements of the polynomial is less than 100. So as described before, you know that it is m by n, and the transpose matrix is n by m, and you can guess that dr and dc should equal to m. Okay, so even though it is described as in general manner, so you can just check it. This should be n. Additional requirements for bonus points: you have to overload the operator output, and the overload the operator should meet the calling convention as mentioned above. And for example, if your input is 2, 3, this means this is a matrix 0, 1, 0, and 2, 0, 5. And the transposed one is 0, 1, 0, 2, 0, 5. Okay, so you have to make an inner product of this first row and this first column, and the inner product should equal to 1. How about this one? It should be 0. How about this one and this one? It should be 0. How about this one and this one? Then 2 times 2 makes 4, and this is 0. 5 times 5 is 25, so the result is 29. Okay, so your matrix is 2 by 2, and you need, this is a space, and you need 2 non-zero elements, so 2, and the resulting value is that 0, 0 is 1, 0, 0 is 1, and 1, 1 is 29, 1, 1 is 29. So your result should be printed like this. And you can check this as 2 rows, 1 column. So -1, 2, and the transposed one is -1, 2. Okay, and the multiplication result should be 1, this one, and -2, this one, -2 again, this one, and 4, this one. So the resulting matrix is 2 by 2, and it contains 4 non-zero elements, and the elements should be, for 0, 0, it is 1. You know that this is checked here, 0, 0, 1, and since it is row measure, you should count to 0 at first. 0, 1 is minus 2. And the next element is row major. 1, 0 is minus 2. And 1, 1 is 4. So your output should be like this. Okay. So you can start from the code of the previous lecture. So in the case of sparse matrix, the CPP, so let me just select this. So let me switch to your Visual Studio Code. So in your sparse matrix, it is using the plus with the rows and columns, but the row and column is not printed here, but the elements are only printed. So you should overload this kind of things. Okay, so you have to print n rows, n columns, n elements at the first line. So instead of this one, you can do that as the first line of this input, n rows, and space, then n colors with the space, and then n elements with end line. Okay, and you are printing every element, but there should be no space at the comma here. Okay, no spaces here, and this should be printed. This should be printed like this. And you can think about that this print should accept string reference out. Okay, then you can rename that. This is not cout, but just out. So you can just out of this. And then you can return. So if you want to return out, then it should return string here. String reference. So with this simple setting, you can modify that. How about the SM element and sparse matrix print? Instead of sparse matrix print, you can just pass a cout here. Okay. Pass a cout. So saving this and build this again. And you can execute this with sparse clear screen. So let me just adjust this a little bit. Sparse matrix.exe. So your output should look like this. This is a sparse matrix. So for the overloading, you have to consult the handout. Okay, and for the transpose, you have to refer the previous video lecture. Okay, and the programming time should start at 9 o'clock a.m. and it will last to 6 o'clock p.m. Okay, so if you have any question, please use the Q&A board, and then all of you have a good luck in this rather top laboratory work. Okay, so see you next Monday, and oh no, not actually, see you next Wednesday in an online lecture. Bye bye. 수고하셨습니다.